Hello everyone, let's solve the AP Calculus BC 2014 FRQ for polar coordinates. So in this question, we see that there are graphs of two polar curves. The first one is r equal to 3, which is this one. And another one, which is r is equal to 3 minus 2 sine 2 theta. And they are shown in the figure for 0 to pi. So this is 0, and then this is pi over 2, and this is pi. Firstly, we need to find the area of R. So the question tells us that R is a shaded region inside the graph of R is equal to 3 and R is equal to 3 minus 2 sine 2 theta. So this is the first part of R from 0 to pi over 2, and then it's under this graph. And then we have the other part of the graph, which is this section, and it's from pi over 2 to pi, and the graph of this is R is equal to 3. So let's just use the area formula to find the region R, and if you are not familiar with this, we have linked the relevant video in the chat before, so you can check out our previous videos. So we just use this expression to find R, and we add up the first region and the second region, and then we find this final answer by using our graphing calculator. Now let's look at the second question. For the graph, R is equal to 3 times 2 sine 2 theta. So it will be this curvier graph. And we want to find dx over d theta at pi is equal to, theta is equal to pi over 6. So we just remember that if we have the expression of R, we just x is equal to r times cosine theta. So we just multiply this to r and then expand it. And then because we can use a graphing calculator for this question, we just put this expression using the math 8 function. And then we obtain this solution. Now let's look at question 3. The distance between the two curves changes in this range, so we need to find the rate at which the distance between the curves are changing. So the distance between the curves is just the distance between the two arms, like R, and the other like theta is constant, so we just need to do like R1 minus R2. So this is the expression for the distance, and then we find the derivative, which is equal to -2. Now let's move on to question D. So there's a particle moving along this curve, and then we are also given that d theta over dt is equal to 3. So you want to find dr over dt at this angle. For this question, we just have to use the chain rule. So this is dr over dt, and then this is r dr over d theta, and then d theta over dt is equal to 3. So we just obtain -6 as the answer. So that was it for the 2014 question. Now let's solve another question, which is the 2017 AP Calculus BC question 2. So firstly, there is a curve. We have g of theta, which is 2 cosine 0, and that's the outer one. And then this is f of theta. So there's R, the region, and S is the region bounded between G and F. So instead of being the whole semicircle, S is only this region. Okay, now let's find the value of R. Again, we just use the area formula if you are not familiar, you should check out our previous videos. And we put this in the graphing calculator and get this answer. Now for B, again, we just need to implement the area formula, this time algebraically. And then we also note that if we want to find the area of S, we square G first and then subtract it by F squared. We don't do G minus F squared. It's just like if you have an array like this is R, this is S. The area is 1 over 2 R squared minus 1 over 2 S squared delta theta. So, but like it's not R minus S. This is a common mistake. So that's it for B. And then now for C, we want an expression which helps us find the difference in length between G and F, which is this expression, as it evaluates the difference in length between G and F. Okay, that was a simple question. And then now let's look at the average. So in order to find the average of a function over an interval, you just take the integral of that interval and then divide it by the length of the interval. So you find that the answer is 0.485. And for the last question, we want to find a value where it's equal to the average. So you just set W of this to be equal to the average. And then we take the derivative to find if it's increasing or decreasing. So here is the work that I have done. I first let the expression of this to be equal the average I have found in the past. And then I use my graphing calculator to find the angle. And then I try to find the derivative, which I found was a negative number, which is smaller than 0. So it tells me that this value is decreasing. So that was it for the free response questions. Thank you so much.